And we're live.
Hi.
Hi. Hi, this is Şule Eryürik from Turkey. I also would like to say good morning to everyone, or good evening, or good afternoon. Thank you for joining us today. So, I will moderate the session for you. So, let me introduce myself. I'm an expert in industrial management engineering with a specialization in lean consulting. I am dedicating to optimizing processing and driving innovation across various sectors. So I would like to, so I'm honored to introduce Shruti. Shruti is an expert experienced AI consultant specializing in machine learning, deep learning, and computer vision applications across various industries. He has developed advanced algorithms for object detection, image segmentation, and faster gesture recognition. Has applied computer vision to areas such as automated optical lens, spectacles deformation detection, and posture recognition systems.
Hi, Sully. Can you hear me?
Her insights on practical application.
I think we're having a little bit of a latency issue, but you're both
Yeah.
audible. You're both audible. Yeah.
Okay, cool.
Yeah, I hear myself one more time.
There is
Yes,
an
I
echo
can
for
hear
you.
you. Echo, yeah, I have been hearing myself almost twice.
I'm not sure if you have external microphones. If you have headphones, if you have external headphones, we could.
Yeah, yeah.
Okay. It might be an audio. Um, might be an audio issue. But okay, Shudri, you are more than welcome to start your presentation. I know we're time is of the essence, so um,
Thanks. So I'm quickly sharing my screen. Uh, and going into the slideshow. So, hi everyone, and thanks, Sully, for the introduction. Just a few words. So, I started my career as the machine learning student and then slowly progressed into now working in the domain of AI for MBSE at Heterogeneous. Today, I'll be discussing on the topic practical application and evaluation of heterogeneous data sources into a graph database for industrial contexts. So, in a nutshell, just about the company so that it sets the forefront of what the talk focuses on and what kind of experiences we have. So, basically, we are an IT services and consulting company, and we have three major pillars. And the fourth one, which is cross cutting everything, is AI. MBSE stands for Model Based Systems Engineering, and we have process methods and tools and certain cybersecurity. On the left, you see the services, on the right, you see certain tools. In which I'll be explaining something about ETMS Analyze in today's talk. And I come from the Competence Center AI, where we provide solutions for each of the systems engineering based efforts inside research projects, which are government funded, and also certain kind of customer projects that has a focus on cyber physical systems. So, quickly look into the agenda. We just start with the introduction, and I will give you a brief about the concept of building knowledge graphs and then how we implemented it by using a case study and certain future works and conclusion on how we see the whole approach. So, I'm not sure if all of you are aware of the term traceability. If not, this is for the people who are starting just to hear the word traceability. Traceability means if you look into the word, you can kind of dissect it into two sentences: the ability to trace something. So basically, inside a systems engineering activity, just like a process of building, let's say, a car, involves a lot of components coming together. So the ability to trace all these artifacts in both the directions, like starting from requirements to your maintenance artifacts, or from your maintenance artifacts to checking if your requirements are validated and verified. That's the whole process of tracing your systems, called as traceability. We have two types of tracing. So one is basically like intermodal connection. So if you want to trace something from requirements to system architecture, then we call it as intermodal connection. And sometimes you also have to trace inside the requirements, like which requirement is associated with which requirement, or which requirement is verifying which requirement. So that is intramodal relations. So this huge cycle of traceability is useful for understanding how industries work in real time. So that's traceability in a nutshell. So, how the current scenario looks like, even though traceability has been there for a long time, we have very low usability tools which are not adaptable to kind of enforce or give like a edge of using this traceability systems altogether. And there involves a lot of manual analysis. Basically, if you heard the talk yesterday by Capgemini, there involves a lot of documents that are coming from different stakeholders to put the traceability artifacts together. That obviously makes the process really tedious. And when you are working in a consortium, for example in our research projects, there involves a lot of stakeholders having similar requirements, and somehow you want to exchange this information with each other, and think about the tools that they have and the formats that we want to do in order to achieve a unique traceability setting. So it's very difficult to have a cross company exchange. But why this is needed to answer all this traceability and everything that is to be done, there is one key factor: we need to be compliant no matter the domain. There are certain compliances that we need to adhere to in order to be market ready, in order to be safe, etc. So in agriculture there are some compliance like ISO 17989, 209966, etc. In cybersecurity we have ISO 26264, and so on and so forth. And we also need to know which of the resources are most needed, how we can efficiently improve the time or cost, or in terms of putting all these artifacts together and handling this heterogeneity. And we also always use this concept of having a co-pilot for the systems engineer. So a systems engineer is someone who works across the traceability lifecycle and has certain stakeholder specific requirements to be met. So can we provide an AI assistant that will in turn help the systems engineer to do traceability? So this is the most need of it. And as I mentioned before, we are involved in several government funded research projects. So one such research project that we were involved is called Impact, basically. So Impact deals with agricultural manufacturers who had certain use cases. So you can see that a crawler truck, which is the bottom part of a bigger agricultural truck or similar, we had balancing machines and certain precision injected molded machine. These are nothing but the components that are made to be inserted into a bigger machines in different formats and etc. There were three companies involved called Klaas, Hoffman, and Hadiplast. It was a German funded research project. So you can also see certain artifacts that I will show in the knowledge graph to be in German. And in a nutshell, I just want to show how this is done using an example tool. So for example, Cameo System Modeler is one such tool that is helpful for doing something called Traceability Information Matrix, or TIM as they call it. So you can see the requirements are loaded into the tool, and then there are like certain system artifacts that are mapped to this requirements. So this is a manual process. This traceability matrix is kind of very tool specific, and you get certain CSV files out of it from which which you build the unified domain model. Of course, you can get the artifacts in different format, but we chose CSV to be one of the formats so that we can later use it in the knowledge graph. And then you have a unified domain model. A domain model is nothing but something that represents your domain and the artifacts on how they are related with each other. So this is like the key factor of establishing traceability inside the company. So, moving on to the concept, I mentioned that we are involved in the whole process of traceability and we have different intra models, inter models, etc. You also need to be aware that there are many tools used by many vendors to store the project information. For example, CSVs can be one such tool. There could be like PDF documents coming in, there could be simply text files or certain user specific tools. So the first thing is to have a form of data source connector. So each tool is different. You need to have like a custom plugin to bring it all together to build what we called as a traceability graph. So on the left, so we use our in-house traceability tools to do this, or I will also show like an NLP stack on how to achieve this. But we have a more comprehensive overview if we have many enterprise specific tools and bringing all this data together. So, how to store this traceability knowledge graph that is being generated? There are certain technologies that have been used traditionally, for example, like SQL databases, like MySQL, on using certain dependency tables. And then there are like no SQL databases like MongoDB, where you store it as documents as a key value format. But both these formats are not really useful for traceability use cases because these graphs become large over a period of time and they are dynamically developed. Plus, you need a flexible schema to do like a analytical situation for this. So that's why we chose graph databases. In this example that I'm going to use, we are using Neo4j, which is one of the popular graph databases out there. And then there are also like many ways to build this knowledge graph, because that's also one of the questions that I get asked constantly. Like, if we don't have the data but we still want to see how this would perform on a lookalike data like ours, then you can also use certain tools to do this. I'm just quickly switching to the ways to build knowledge graph. If you're a beginner who's just looking for knowing the knowledge graphs, you can start with like tools like Seolsology. And there is also like advanced methodologies like using NLP, for example. This is how most of the knowledge graphs are built in general, where you have certain unstructured data that you do to parse and clean up. And there are models that are specifically trained to identify keywords for each domain, like named entity recognition or topic modeling based on the use case that you're handling with. And then you put it to the graph building pipeline, where you get like nodes, edges, and certain properties for this nodes and edge properties. Then you ingest this into Neo4j. Also, like a quick overview of how we could I'm not going to deep dive into the code, but mostly like Neo4j also has drivers in different languages. This is one using Python, where you can dynamically inject this queries into Neo4j. So the query for creating a set of nodes from CSV files looks something like this. Once I have my requirements, I have certain properties of the requirements like IDs, names, text, what is the priority of the requirement, any kind of types that are used in this requirement. So once you have the CSV files, you have certain headers in the CSV files that you can then use it to type like an ASCII format. This is a simple pandas manipulation of taking all the column values and using it to be like the one cipher query that is then injected into Neo4j basically. You can also find it in the link below, and also have a look into the blog post for more prominent approaches of building knowledge graphs. So how does the domain model look like in the end for the three use cases that I showed before? So you can see that we have like requirements sorry So we have certain like requirements, functions, logical elements, and physical elements, where it has certain relationships with each other. Then we also had an exchange format, because once you use something like a traceability tool or an NLP pipeline to get the answers for your knowledge graph or sending it to the user, then you need a dedicated exchange format. So you can see we have node types, edge types, node instances, and edge instances that represent how the data is being transferred across different services that you build during the real-time operations. So first step is to identify the tools of where to get the traceability data, and then you use the data source connector. It can be an AI powered tool or a traceability tool to build this set of source and target relations and other properties to build this schema. So the one that I'm showing here is actually extracted from Neo4j, and this schema is quite flexible. We'll also see it in the video. So, how did we implement it? One of the main objectives of using traceability is that we need to handle change requests. So, this process is called change impact analysis. You have a process which is going on, and then the user or some stakeholder comes up with a new change request. Let's say I want to change the color of a crawler truck from red to orange, for example. Then you need to find out what is the scope. You need to see which elements will be affected because of this change, and what is the level of granularity that you have to achieve in the system. So sometimes a traceability within requirements and functions are well enough. Sometimes you have to find like the physical elements that will change when you change a certain logical elements, etc. So this can vary according to the level of granularity that you are looking into. So, certain sample questions that the user can ask to the traceability graph is that what requirements has changed, which of the requirements are kind of together, which of the requirements are far. That's where we use graph based algorithms. This graph based algorithms are available pretty much in Neo4j, like finding paths in your graph, finding communities in your graph to identify which requirements are same, which logical elements are clustered together. That in turn verifies if this path is being satisfied. For example, a requirement can be marked satisfied when you start from the requirement and go until the maintenance artifacts, to give a feeling that the whole graph has been satisfied and your requirement has been verified. And then when you're doing compliance or something like this, you have to get some specific ISO artifacts. This can be also done by searching through the graph without going through the big stack of documents that you would have. And some low hanging fruits could be like market analysis and cost analysis based on templates that you have. The same company is planning to enhance certain aspects of a particular crawler machine, or they are planning to reduce or increase cost of a specific component. um, so this was something that we did during the research project, and then there was the RAG based systems coming into play. LLMs were kind of like growing, and it was at the end of the project we integrated certain aspects to answer certain questions of the user. So when you use Neo4j, you have to be little bit aware of the cipher queries that you write, which is really not the job of the systems engineer. So they had questions like give all the impacted requirement nodes for change in function, give all the impacted physical elements related to logical element, and what happens if I increase the cost of the physical element by 10%, which ones will be affected, etc. And then they use it to estimate or mark a certain change that has happened in the requirement. We'll see this with the live scenario. Before we go into the live scenario, I would also like to just maintain out this is a simple graph rag approach that generates a cipher query for the Neo4j database. This is a classic example of using a graph database as a source for having our queries answered, that also has certain semantic understanding of the nodes and edges. So you pass on the schema from Neo4j, and then analyze the question of the user, and then build cipher statements like this. So this template is a classic one shot learning, but you can also adopt like a few short learning examples based on your data and domain. One of the tips that comes handy directly from the LangChain Neo4j effort to make this happen is that it can be really enhanced if you know the distribution of the data and the value that the question needs to be answered based on the schema. So you can kind of like include and exclude what to use from the schema that is extracted from Neo4j. So this is a sample template, and then let's see the live scenario. So this is the same domain model that I have modeled in Neo4j by using the CSV files. We have certain requirements properties, so you can see the requirements nodes and associated properties with them, and also certain relationships as types like decompose, derives, and also keys for each and every nodes that we have. So one question that I have asked here is like, give all the impacted physical elements related to logical elements Lagerung. The word Lagerung just means like storage. As I mentioned, this was a German research project, so some words are in German basically. And then you get results such as the physical elements which are related to this particular logical element, and also the cipher query is generated. So once you get the cipher query, you can also test it directly with Neo4j and visualize it as a bubble chart or certain kind of information to pass it on to the next services that is using it, or just simply showing it to the user. So you can see all the different connections for this particular logical element here. So this is one classic example of how we used the graph rag approach in answering user defined questions for deeper domain knowledge and also to perform change impact analysis. So certain real-time examples from the use case itself is that, let's say you want to change the mid rollers of the crawler truck, then the original approach is to get the path of the functions which are affected, the logical elements which are affected, and the physical elements that are kind of like coming together to find out which particular physical elements needs to be changed for this particular change request. This is a classic domain of agriculture, and this is one of the elements of understanding how it impacts and which functions, which logical elements, which physical elements needs to be satisfied for addressing one particular change request. So coming to the next part of it, which is basically understanding the pros and cons of the approach. If we think about the pros of the approach compared to traditional RAG system, which is retrieval augmented generation, where you have a bulk load of documents and you feed this as an input to a large language model or a small language model and ask it to understand the context and give it to you. But in graphs, it enhances this contextual understanding because you're providing like a schema, and it has lesser input tokens that could be used for getting good quality queries, that is in turn giving you the context that could be processed based on these properties. So this also improves the accuracy of the retrieval process, and you're no longer searching for a needle in the haystack. Basically, you're not going through a lot of documents to find out which of my elements have been impacted, so on and so forth. If we come on the contra side, the setup at the first glance may look complex if you're not used to like the graph databases or setting up certain like open source technologies or who is having governance of what and etc. Then this could be like a contra, and it also depends on the data that you have. You need to fill out all the node properties, all the edge properties, so that your data is always like full, and this needs to be ensured for your RAG system to take this data and use it accordingly. And of course scalability, because traceability graphs, if you think about certain systems like building a car or building a space satellite, then you can expect an enormous huge load of artifacts up to like 500 k plus connections, 5000 k plus nodes, etc. So you also need to make sure that the system is well scalable to adapt these changes as time goes by. To give you also overview of how our tech stacks look like. So I mentioned the database is Neo4j. For doing some graph-based manipulations, we use the open source technology called NetworkX. And then for using out-of-the-box graph algorithms or graph-based transformers, we use something called Stellar Graph, but you can also use Scikit Network or PyTorch Geometric, which is also widely known. And for evaluation, we use LLMs hosted sometimes using Olama, or we were previously experimenting a lot of it with, as usual, like the Azure version of ChatGPT. But recently, we also switched completely to open source, having everything on premises using Olama, and monitoring using the RSAI service called Phoenix, basically. So this is the whole tech stack in a nutshell. And coming to the conclusion, so the aim for us was to model a traceability graph that represents the domain. But if you look into the traceability graph, you can analyze several result dimensions that one needs from the system, because each stakeholder is kind of like different and they want certain information from their traceability graph. For example, a manager just wants to know how the system is progressing, what is the time that is needed to complete this particular project. On the other hand, a systems engineer is very much interested to know which requirements are mapped to which functional elements, or which logical elements are related to which functional elements. So it helps you to analyze the result dimensions using graph databases and AI to bridge the gap of reducing the cognitive load of the systems engineer. So this can be in general generalized to multiple domains other than agriculture. And also, when you combine AI and traceability, it's not only about like tracing the artifacts with like one requirements to functional elements or one functional elements to logical elements, but you can also like predict, analyze, and also optimize the process of how you do traceability inside your organization. So these are few comments and feedback from the stakeholders who started using the system during the research projects, where they highlight this does exactly what we called as impact analysis, and they were very much interested in see how these paths are very easy to retrieve rather than going through documents and talking to different people. And also previously this was done manually, which led to considerable delays and additional costs, and now with the systems and technologies like this, they can adapt to have a more automated way of approaching the problem. So as future work, so this is like not like a very much future work, we are doing these things also parallelly. I showed certain tools which are very enterprise specific, like for example Cameo. We have integrated certain POCs, certain helpful features for traceability, or doing some NLP tasks inside this Cameo system modeler. And we are also adopting it to other industry research projects like cooperance, for example, where we are dealing with pretty much complex meta models for space domain. And then as I mentioned, we are switching to many open source technologies rather than using closed source LLMs due to the obvious reasons, and also experimented with certain small language models like llama 3.21b for summarizing the outputs of the graph rag and etc. So this is something in progress, and probably something to present for the next time. That's end of the presentation, and we have good time for the questions. Thank you so much for listening. Open to questions, feedback, and comments.
Oh, Sulu, you're on mute.
Thanks, Shruti. It was an amazing presentation. Thank you. So is there any question? Let me check. Okay, so I have some questions, if possible. So why is an integrated approach necessary in today's data-driven decision-making processes for industrial contexts? So why is an integrated approach necessary in today's data-driven decision-making processes for industrial contexts?
Yes. So basically, when it comes to decision making, you need to have a wider look into the data in order to get the necessary information. So if the data is kind of like spread across different departments and different domains, then it makes it relatively difficult for you to bring everything together and also like get the essence of what kind of decisions that you should take based on the solutions. For example, if you think about a traceability system that is distributed, you need certain unified approach to bring everything together, such as the graph databases, in order to answer questions more promptly and more efficiently. So for example, in traceability, when you're having like a huge change request and it affects a requirement which has a priority of 3 or 4, meaning that it is associated with certain kind of like artifacts, then you need to make sure that is already like a resource allocated to this particular task. So this decision need to be made based on the data. So once you integrate this process and have an overall outlook of how this is affecting different aspects of the decision making, then it makes sense to have certain integrations into your day-to-day activities or day-to-day tools to have an overview of what you want to achieve in the upcoming future, basically.
Excellent. I have one final question for you. In your extensive work, what do you prioritize in your roadmap of projects to come down the pipeline?
I think the first priority for us is to have certain kind of infrastructure so that the users can easily like onboard into using it. Like, for example, using certain kind of infrastructures to onboard users for using Neo4j, using certain kind of like hosted on-premise hosted services like using Olama, etc., and making them aware that what are the things that are can be set up easily into the project, and what are the things that needs to be discussed further. And second importance is also the data. How can they bring all this data together? What are the different kind of setups that we would need to bring this data into the LLM or in general AI specific use cases to bring everything together? So the infrastructure and data are the two things that we always like keep in our mind before we build something for the client or addressing their questions in terms of RAGs or in terms of NLP based applications.
Excellent. Well, thank you, Shudri. Thank you, Suli. We're going to take a brief break, and then we're going to come back with the first panel discussion of the day. We're looking forward to a follow-up in tomorrow's panel discussion with you, Shudri. So stay tuned for now. We'll be back in about 19 minutes.
Yeah.
Thank you.
Thank you.